Hey folks, welcome back. So last video I built a router that classifies GPU traffic into three different tiers. If you want to watch more about that and then go through the entire setup, I'd recommend you watch this video, Adaptive Inference Router Matrix based gateway for vLLM. So today I will talk a little bit about the router logic itself from a very high level, just so that we're back in the main picture. So essentially what happens in this setup is that, say, a user request comes in through our UI, right? So there's a inference router that sits in between the vLLM pods or the GPU pods. So what this router does is that it will make certain decisions depending on the state of the cluster. So there are like three distinctive decisions that it can take, right? So either it will be red. So if things are bad, red means your request gets rejected. Your request won't be sent to the backend LLM pods anyway. And the other one would be yellow state. If the cluster is in a yellow state, what will happen is the maximum number of token that you can get back on your reply will be limited to 128. So it's not like a full denial, but you will get response back from the UI, from the vLLM pod. But then it will be limited to 128 tokens. Not all of the response might need that amount of tokens, right? But if you do need more than that, it will try to wrap up at 128 tokens. And then if it's green, meaning everything is fine in the cluster, then our max token output allowed per query is at 512 tokens. So you will get response with full tokens if you need it, right? And again, among the situations, the other logic that this router part implements is that depending on which backend part is the healthiest, it will forward the request to that part, right? So there's a bit of a weighted load score here that does all of the calculation and finds out which part is responsible for handling the request, which part should get the request, and so on. But I've explained all of that in great detail in this video, so if you like, I recommend you watch it if you want to kind of recap on that. So for today, what I want to talk about is the dashboard that I've built. So previously I didn't have a working dashboard, right? But now I have this dashboard here. So let's go through a couple of tiles that we have here, and then we'll go through some examples, right? So current here, that tells me what my cluster is right now. So it's in a green status, everything is fine. And then that's the polar health, right? So what happens is the router, right, like it has a polling logic. So let's imagine like I have two vLLM pods in my backend. Then it kind of sends the request every couple of seconds to the backend vLLM pods to find out what is their current health, how many pods are active there. Let's say if I scale my cluster and add another pod there, then the router will be aware from the background polling that okay, there are three more pods and so on. So that is the router polar health. And then the queue depth is about like, okay, how many requests are queuing up right now. And then the KV cast is about the that's an aggregate of all the KV casts that I have in each of the pods. So in my situation now, I have two pod counts, and then historically how many requests were said. So I did some testing before this lab was set up. So it's about at like 1792. Were there any degraded requests? So there were five requests that were degraded, right? So these are the big block tiles here. And then as you can see, there are a bunch of other fields as well. So this is like tokens generated per pod. So as mentioned, I have two pods. You can see that the distribution is good enough. So this tells me that my routing logic is kind of working as expected, right? So there's not a massive difference between these two pods. And then that is request served per pod, and a bunch of other metrics that might be helpful to know how many tokens are being generated, how each backend pod is behaving. And then the other important thing that I haven't been able to figure out, and I kind of want to go into the depth, is the queue does not really increase at all. I have a feeling maybe I'm not overloading the system too much, or I kind of need to understand how vLLM batching and scheduling works as well. So that's something for maybe future. And then the other important matrix here is the KV cache users per pod, right? So we know what KV cache is, but let me give you a brief overview of what will be the situation in my setup. So in my setup, what I have is I have a 12 GB VRAM in my GPU nodes, right? So I have a node that has two GPUs, and then it has 12 gigs of VRAM on each of them. So 1.2 will be used for the CUDA overhead, right? So there's not the vLLMs. That's an estimation again. So the remaining 10.8 gigs, I have set a config map value in my cluster where I say that the GPU memory utilization should be 90%. So 10.8 gigs is claimed by vLLM. My model weight is around 6 gigs because I'm using Qwen 2.53 billion BF16 model. Let's give another 500 MB for runtime and activations. So again, these are kind of estimation. So there's about like 4.3 gigs left for KV cache, right? So that's my 100% of KV cache. So based on how busy the LLM is, this value goes up and down. So I do have a good bit of space left for my KV cache. So like it's never really gonna max out or spike out because I'm not really hammering it too much. And then I kind of wanted to leave good bit of space for KV cache as well. Like in this setup, I could have tried maybe a bit heavier model that will use more more vLLM, maybe 10 gigs or 8 gigs even, a 4 billion parameter model. But this is okay. And then I think leaving enough space for KV cache makes the model faster. Again, I'm not 100% right, but these are the things that I'm trying to kind of test and find out myself. So in this setup, for me, there's enough space for my KV cache pool. So even if I get a lot of requests, my GPU should be able to handle it. My LLM has more than enough resources to go through all of those things, right? So let's do some demonstration and let's see how things work. So let me minimize that. And okay, so I will run a Python load test here. So let me go Python 3. So there are like a couple of test matrix in my in this Python load test script. You can find this in the repo as well, right? So now this is like it will send 20 requests, 5 concurrent requests to that particular endpoint. So now we should see some matrix being populated, right? So it shouldn't take too long for this to come back up here. Okay, there we go. We see that I'm only using 0.4% of my KV cache when I'm doing a light test. You can see that the number of requests served per pod has gone up. The tokens generated has gone up as well. And then all of the requests should be fine. None of those requests should be in a degraded or a setting state. All of them should be served. So again, bunch of other matrix that are quite important. Here we go. It says that all of the requests were in green tiers. As we can see, it's green here. Nothing was setted, right? Everything went fine. 50% load distribution. So let's change this to brutal, right? So this is where we should start seeing some different matrix. Okay, so in brutal, what happens is we're sending like 2,000 requests, 200 concurrent requests at a time, but we don't want our backend system to collapse or the quality of response for X amount of requests to go down. Hence, if the system is overloaded, we just shed the request, right? So we'll see this number going up, and then some requests might be served in a degraded state as well. So let's see how this goes back up. And the other thing that I've noticed is sometimes my polar health says it's down. I need to kind of figure out why that comes as down a bit, but yeah, it comes back up okay. But yeah, it's something I need to spend my time on. So as we can see there, the current state is at red because we were being hammered with a lot of requests. We set it 3,584 requests in total. So the 1792 requests that got set at this situation, remaining 208 requests were completely served. And the KV cache in this situation went all the way up to 24.2% utilization, right? So we see those matrix change there. Now the KV cache has dropped back to 0. The cluster is on a green state. So let me check if I can tweak this a bit more again. I think I had different modes here, which is sustained. Okay, so let me run one more test and then we'll wrap the video up. Sustained. Okay, so it's sending 300 requests with 30 concurrent requests and every 3 seconds, right? So sends a bunch of waves, and let's see how things go. Okay, there we go. The first 30 requests, all of them were through the green tier. Everything went fine. KVCast value goes up, and yeah, I think, to be honest, like, that's all. That's what I wanted to kind of say in this video, right? So these metrics are important if you're serving an LLM on the back end. Again, I'm learning as well, so there are probably much more important metrics that needs to be studied. Yeah, so I think this is okay. The system can handle this. There's not a lot of load on the system, and we can see everything is decent enough. So yeah, thanks for watching this video. I think in the next video, what I want to do is I want to go a bit deeper into how vLLM works. Now that we have a working setup where we have a UI, through the UI we have two different backend vLLM pods. We can talk to our LLM in the backend, and Kubernetes is implemented in the cluster. So we have enough to get started. So now it's time to kind of drill deeper into how vLLM works. So thank you for watching this video.